Hi, this is an introduction to the NAD 5120 turntable. I've just been given this example from a good friend who runs a second-hand hi-fi store, and he knows I'm interested in this deck, and he said that this one I could try out because it had some motor noise. These decks were made by actually a company in the former Czechoslovakia back in the 1980s called Tesla. And this model of deck was called the Tesla NC470, and NAD rebadged it as the NAD 5120. It's quite an unusual deck in a number of ways. If I lift up the lid there, we have this polycarbonate lid. It's not your conventional box section lid, it's open at the sides, and these raised end cheeks mean that you have acoustic isolation for the turntable when playing. Now, this particular example is a belt drive deck, so here we have the belt, and you can see over here the arm. Now, this is one of the later round arm models, and these are the ones that are more frequently found. Earlier on, the deck actually was issued with a flat arm, so that was quite unusual looking, flexible flat arm, and I'll talk about the arm in a moment. The platter is unconventional. It's essentially a rubber mat on a steel under platter that forms the main platter. This one's locked down because it's got its transit screw screwed in, so I'm going to unlock that in a second, and I'm also going to try that motor. So the first thing I'm going to do is close the lid, nice and safe, and underneath the deck, if you can see there, it's a wheel, that's a transit screw, so you unscrew this and the sub-chassis can then operate. So just keep unscrewing, and eventually it'll be very loose and you can't unscrew it anymore. If I lift up the lid, you can probably see now, oh, something's not right. Probably slid off its springs underneath. Okay, well, let's have a look underneath. So there's the mat, there's the sub platter, which is actually the wrong way up, so probably that may be the problem. That normally goes that way around. There we go. You put the mat back on, there we go, we've got a floating sub chassis. That's to isolate the turntable from external vibrations. The mat here, this one's in lovely condition. Normally these come all grey and marbled. You can wipe them with a cloth, or you can wipe them with Platin Clean print roller restorer. Here's the simple steel sub platter. Okay, that's fine. So here you can see this is the spindle, and here's the motor. Just going to try and see if I can get a bit the camera a little bit closer. There we go. So it's a belt drive turntable and uses 240 volts AC in Europe, or 110 volts in America, and so it uses the mains frequency to set the speed. And here you see the speed select. This mechanism essentially moves the belt from narrower diameter to a wider diameter, depending on whether you want 33 or 45. Here we see the spindle, the sub-platter plastic system, and then we have, you can see this T-shaped floating sub-chassis. Now, the first thing to do, as this deck has been diagnosed as being noisy, is let's see how noisy it is. So, up until now, I've done all of this with the electricity disconnected, and that's very important because these decks run on mains electricity, so you should never dismantle the deck with it plugged in. So I'm just going to plug this in briefly just to see how it sounds in terms of motor noise. Now, this particular turntable has a simple function, has this simple stop play on the front, and you can see there, maybe you can see that there's an orange light. So this is one of the early ones which used an orange bulb. Some of the later ones had a red LED. Now if we swing that in closer, yeah, you can probably hear quite a lot of noise coming from that motor. And if I touch the chassis here and here, I can feel that going through. So what that means is I need to essentially disconnect the deck from the mains, remove these screws, remove the arm, remove the lid, remove these screws, take the motor out. There's a sponge that decouples the motor from the sub-chassis, sorry, from the plinth, and I need to disconnect that. And so, a few things to do. Now, the lid lifts off, and at the back here we have these simple hinges. Actually, I should turn it off from the electricity before I do anything. Be safe. Now these hinges just pull out, and these are the same hinges that a number of decks, including Lynn, use. So they just pull out, and I'll take those over there. So if I swing the camera around, let's remove the arm, and here we see that this arm actually pulls off completely. So if I slide it up gently, gently, the whole arm comes away. You can see there's 4 pins here which engage in this socket, and you can swap arms. You could actually buy multiple arms and have them set up accordingly. Now the arm itself, let's bring it in front of the camera. Very unusual. It has this floating weight assembly here, you can see, an oil chamber for damping. So it has this anti-resonance feature, so in addition to setting the weight conventionally as you would on any towed arm, you also can control the damping by extending a pin into this oil bath here, and also by tightening the length of the spring that's included in here. Now actually normally this assembly is the other way around, so I'm not exactly sure why this one's been set up like that, but yeah, an unconventional arm. This is the later round arm version. Earlier ones had a flat ruler type, and I'll show you one of those a bit later. This one's been fitted with an Autofon OM series cartridge, very commonly found on these decks and capable of sounding very good. The OM range starts from the OM3, OM5, 10, 20, 30, 40, and the nice thing is, just by replacing the stylus, you can move up the range.
Who are you talking to?
Okay, so let's dismantle some of the deck. So the central spindle here, which you can see, a couple of key things here. This copper washer is very important because this maintains electrostatic contact between the spindle, the copper washer, and the steel platter that goes on top, and this provides an electromagnetic screen from the cartridge to the motor, so tries to reduce the amount of hum. If these decks have one Achilles heel, is that they can hum, and partly that's down to the strange grounding arrangements that exist here. But anyway, it's important that this copper thing is there. We pull that off. You can see here that the spindle, actually the bearing is a lot thinner than the outer spindle. I don't know if the camera's able to pick that up, but this is unusual because normally the main bearing goes down, is actually fatter, but this one is actually thinner, and it goes in, let's put that to one side, to a small assembly here. And the interesting thing you will see in a minute is that the main arm bearing uses precisely the same assembly. So we have a brass sleeve, plastic outer case here, plastic outer moulding. This contraption here is an auto raise at the end of the side, which sometimes works and sometimes doesn't. And here we see the whole sub-chassis moving around. So I'm going to move back a second. Let's take this apart a bit more. So there are 3 screws. And now I'm confirming here that this is disconnected from the mains. So you just need a good Phillips screwdriver to remove these screws. Now these decks are made of plastic, but the plastic is fairly substantial, and so I've taken these apart many times. In fact, I've taken the same deck apart many times. Keep the screws safe. Now at this point we can remove the top part of the plinth, and the way I do this is simply to apply a little pressure underneath, and then it comes away. So here we've got the top of the deck, which is again plastic, has these kind of mouldings around the inside, and here you can see the whole of the inside of the deck. Now again, I can't stress enough that this deck has been disconnected from the mains, and here you can see over on one side, here's where the mains comes into the deck. You've got a suppression capacitor for the sorry, that's not the suppression capacitor, that's the phase capacitor. So you've got mains driving the motor, you've got wires round to the front of the deck to the switch here. This switch enables you to turn the deck on and off. It also controls the arm lift, and inside here a little blue suppression capacitor on the switch, and over here you've got a yellow capacitor, phase capacitor, which basically sets the motor, drives the motor spinning in a particular way. You've also got here this strange sled contraption. All AC motor belt drive decks have some kind of system where the motor, or rather the belt, is moved onto a different diameter part of the motor spindle. So here we have these slots here which flip the belt up and down, I suppose a bit like the derailleur systems on a bicycle. So here you can see the speed selector slides that in and out. Now this sled affair slides inside these plastic brackets, which are in turn form a grip on the motor. There's the AC motor. So the next thing to do is to see if we can take this off. Now, one of the aspects of this particular deck is that there is usually a screw. Let's see if I can find it. There's a grub screw which holds. Alright, I'm going to need a different screwdriver, but down inside the top of there is a tiny angled down grub screw. Once that's slackened off, I can remove the spindle. Okay, so the spindle, the motor spindle, has this assembly on top, and there's a grub screw here. You need a really small crosshead screwdriver, and if you can get it into the hole, there we go. Now I've seen some of these where it's very hard to get this working, but here the grub screw's coming out. It's a little bit angled. Oh, and I've lost the grub screw somewhere, but essentially that means that this comes off. I'll find that again in a second. Right, so that means that we've got access to our motor here. I've got my Phillips screwdriver. I can remove these screws. Now this one, there's been some paint or nail varnish or something being put on these, presumably to stop people from doing what I'm about to do, but anyway. Now I keep all my screws and washers and things carefully to one side so I know where they go. You can see here is the plastic assembly that acts as the guide for the speed change. In fact, I'll just put those inside the chassis there. Take out the second screw. And that comes off too. And now, if I'm careful, I can free this. Now this is a little bit fiddly, but if I do that, you can see that this is riding on this assembly. That pulls off, and that comes away on there. So that slots in there. You should be able to just twist that to one side. Now, a little bit fiddly. This assembly here, this actually just slides out, and here is my motor free. Just let that slide back there for now, put it to one side. Now you can see there's a hole there, the motoring sits on top of that hole, and on the bottom side of the motor is this little sort of donut shaped bit of foam. Just tease that off gently. Looks like nothing, but in actual fact it seems to work very well. Whenever I've tried to replace this with a different material, it's never worked as good as the original. So what I normally do is take that, wash it in some warm water, it regains a little bit of its suppleness, dry it out and put it back. So now we have our motor. Now, as I've said repeatedly through this, the deck is very important that the deck is disconnected from the mains. Now these are AC motors, and if you look round the outside you can see here there's like a little slot. There's one there, and there's one there, and there's a third one there. And if you have a screwdriver of the right size, which I'm just looking for, you can use it to prise this open, because the main reason why the deck is noisy is because, I think, is because of dirt build up inside this assembly. So here we have a screwdriver, so I just apply a little bit of, what I do is I stick the screwdriver in, just twist it a little bit, go to the next one, twist a little bit, go to this one, twist a little bit, and you just have to work your way around. The best thing to do is just a little bit at a time, and again. This is a compression joint, and you have to ease it open very gradually, and after a while it starts to free. So I'm working my way in sequence along the 3 slots here. And after a while you can tease it open. So what have we got here? Well, we've got the rotor which goes down the centre, and this actually just pulls out normally. There we go. So that needs a clean. Down inside the motor, and again I don't know if you can see this, this is what's called a thrust bearing. So underneath the motor is this little dimple thing here. Inside that, I can see it, is a little ball bearing which the motor assembly sits on like that. So you can get some dirt build up there. And then we also here have the collar bearing which the motor sits through. Now I've dismantle a number of these decks, and usually this is all absolutely perfectly clean inside, and this one's no exception, apart from sometimes this is a little bit dirty and this bearing in here is a bit dirty, so these need cleaning out. Just going to go and get some more equipment. Okay, for the next part I need some tools to clean this bearing and this motor, and I tend to use these cotton wool buds, the kind of things they sell in chemists. Here's some matches. I'm not interested in the strike end, I'm interested in the flat end. Down in the bottle of this well is a ball bearing. If I put anything metal down there, there's a risk of scratching it, so I have to use something that's softer than metal, but it'll get inside that, and a match head is actually pretty good. Right. The other thing I use is some alcohol. So this is isopropyl alcohol. It's a good cleaner, it's a good solvent, should never ever be drunk. This is purely for, very dangerous if you were to drink some, this is purely for cleaning purposes. So I've got some on the end of the cotton wool bud, and I'm going to clean inside here, and probably, oh my word, yes, that's, can you see how dirty that is? Alright, so let's get that right inside there. That, in fairness, that's probably mostly the old grease that was put in the motor when it was first assembled, but anyway, let's... Alright, so that one's pretty dirty. Now, at this point, I'm going to pour a little bit of alcohol into a little cup and stir my match head and get that in, because I really need to work that right into where that bearing is, and the match head, I don't know if you can see there, that's pretty dirty too. Now I need to get the clean bud, get my motor, just clean off any dirt that's accumulated on that, just run that around there. And use the dry end to wipe away any other dirt. That's nice and clean now. So previously there was a lot of dirt and debris built up on there, so that's nice and clean. Let's just have another quick clean in here. That seems pretty good. You can feel the ball bearing in there. The other place that's important to clean is inside this collar bearing. So let's have a look. So there's quite a lot of old gunk and grease in here. When the motor was first built, assembled, they would have used some kind of grease, silicone grease, something like that in there. Let's just give this a bit of a clean. And it's probably that's hardened, got a bit dirty. Obviously there's some friction involved in a motor continuously, so the metal parts may fractionally wear over time. Now if I just run that match stick there, just to clean that off. Right, so that all looks nice and clean there, there and here. So the next thing is to lubricate this. So I'm just going to go and get some grease and I'm going to re-grease it, then we'll put it all back together again. So I found my lubricant for the motor. This is Servicol silicone grease. So what I'm going to do is use again a clean matchstick just get a tiny little bit of this on the end. It's not very much, not a massive amount, just a little bead of silicone grease. That's a bit too much. Twist it round, put the grease to one side. So what I need to do is get this inside the lower part of the bearing. So just push that in like that. Little bit's gone in there. Then grease up the end of the rotor bearing here. And so that should now fit in there nicely. Now, one thing I'm a bit concerned about is there's some markings on the outside of this, so I'm just going to get a rag and give that a bit of a wipe. Once again, using the alcohol just onto a bit of kitchen paper here. So I'm just going to wipe that around the outside like this, because any grease that's on there is going to affect the electrical contact and the magnetic field of the motor, and it's not going to be a good thing. Okay, so just gently roll that around like that. Okay, that's not too bad. So I've still got my grease on the end of here. So that goes into there. Okay, and now let's just untangle these. So we now have the top collar, and this also needs to have some lubricant added. So again, a bit of silicone grease here, and just stick that in there, run it round inside there. That's fine. The trick here is just to use just enough, not too much. Less is better. And now you push these two halves together very carefully, and you line it up based on where the two wires are in the base there. You can see. So in essence what we need to do here is just push these two halves together. Now you can push it quite a long way with just finger strength, but you will find that it won't go quite far enough. So at this point you need to get pliers. I use these kind of plumber's pliers here. Set this to the right gap, and similar to when we opened it up, it's just to give it a little squeeze there, a little squeeze there, a little squeeze there, a little squeeze there. Just work your way around, just a little bit at a time, just gently, and it'll come together. So the trick here is not to squeeze too much, and eventually the two halves will come back together nice and, yep, all the way around. Good. Now, it feels pretty smooth. There's a little, I can feel the cogging of the motor, but that's normal. The fact that the ferrite core moves through the different coil sections. So all I need now really is to put it back together with my special foam insert, and we'll fire it up and see if it's any quieter than it was. Okay, here's my foam donut. It's a little bit perkier than it was before, so I just stick it over there, and so it's in the special place on the plinth. Now here what I need to do is line up the motor, and the motor's sitting on the foam donut, and these wires go through here. Now This is a little bit complicated because what I have to do is engage the speed select disc here with that. There we go. That can go backwards and forwards like that. So, and now I have the two side screws which support this frame. So these have to slot in. Just finger tighten that one. Ooh. And here we have the second one. So just put that there. Now I found with this deck that though it is made a lot of plastic, or made of a lot of plastic, it's actually pretty robust. So whilst it's plastic, it's mostly made of plastics which are quite robust, support multiple dismantlings, etc. Let's just check that our speed selector still works. There we go. Now the mains cables go down there, and we use this contraption here to kind of slide over it. Actually, I realise at this point I should have put that on first, so let's just take that off. Done this many times, I still make the odd mistake. So slides down there, and then this goes on here. Seems to be pretty good. Right. Now I haven't put the motor spindle on yet, but let's just see now. I'm going to plug it in and see if that's any quieter. Moment of truth. Carry it off at the front. Let's give it a go. Silent. Now obviously I shouldn't stress the fact at this point the whole deck is live. It's open. I've got flammable liquids around, so I should remove those. But the point I'm trying to make here is the motor is now running and it's completely silent, so I'm quite pleased with that. Right, I'm going to power it off and put the whole thing back together again. Okay, so I've reattached the spindle here basically pushed it back on and tightened the grub screw that was down in there, so that's nice and clean. It still engages that. Whilst I've got the platter off, what I'm going to do is use one of my cotton wool buds just to clean out the inside of the bearing well. So I've put a bit of alcohol on the end of a cotton swab there. Let's just see if I can fit that down in there. And a little bit too much. There we go. Out. As you can see, it's pretty dirty on there. Okay, so got myself some more cotton buds. Let's just push that down into there. Give it a bit of a spin. I guess you keep doing this until it's clean. Let's put a bit more alcohol on that one. Yeah. Well, there's always a risk that you leave the cotton bud down there, but that's easily sorted out. Just give me a second. Right. So I've sort of been teasing the cotton bud out with a match. There it is on the end, so that's all nice and clean in there. So, back to my sub platter here. Again, I would use a bit of alcohol and a rag just to clean that off. And again, a little bit dirty there, so that's just the wear and tear. Incidentally, this funny thing here I think is the auto stop at the end of the side. So before I put that back in back into the turntable, what I'm going to do is going to use, I've got an oil can here, so this has got SAE 20 motor oil. You might use sewing machine oil or gearbox oil. I'm just going to put a tiny drop. There we go, tiny drop on there. It's not going to need very much. Let that run down there and then drop it into place. Now it's spinning nicely. And the other thing that I need to clean, which perhaps I should have done before, is to put some alcohol on a clean cloth. Just run it around the outside of this. So if I put it on here, because that's where the belt's going to rub, so there may be carbon deposits or rubber deposits over time. In fact, again, you can see there it's a bit dirty. Let's find a clean surface. Right, now whilst we're in this mode, here's the original belt, and again using a rag that's got some isopropyl alcohol, just pull that through, just clean off any dirt and grease that's accumulated on there. You can see on the paper a little bit dirty, so this goes around here. Put the belt back on. Right, So that seems to be belts on round the spindle here. Let's see. Now again, I'm just gonna try this with the power on. Very dangerous to do. Normally you'd have the lid on, which will protect you, but just to prove that I'm making some progress here, I'm just going to try this as it is, keeping my hands well clear. Right, now from the front, let's turn it on. That's completely silent as far as I can tell, so that's good. Cleaning the motor, washing the sponge, putting it all back together again, a little bit of oil on the spindle, and essentially now this deck's ready to be put back together, cartridge set up and the correct tracking weight and anti-skate and everything else applied, and we're good to go. Great.